Good morning, everyone. My name is Ubaidullah Hafiz, and today I'm going to present Ceer. Ceer can predict optimal GPU instances for a given CNN using empirical analysis. Let's get started. Deep neural nets are being used in a large variety of applications ranging from healthcare, stock exchange, cloud services, or even social media and many more. However, not all DNNs are the same. For example, CNNs, being more suited for image data structures, are more popular in healthcare, social media, and advertisements. CNNs are primarily composed of convolution and pooling layers, which makes them suited for image-like data structures. Figure on the right shows high-level structure of a popular CNN, Inception v3. However, training a CNN on large datasets is very compute intensive. For example, training Inception v3 for one epoch of popular ImageNet data takes a few days on a commodity CPU, a few hours on a single GPU, and can be done in less than an hour when using multiple GPUs. But GPUs are expensive. However, one can rent cloud instances of GPUs for a fraction of a cost. Cloud providers typically offer a variety of GPU instances. Table shows some of the offerings from Amazon Web Services. Different GPU instances have different advantages. Deciding which GPU instance to use for a given model is not very straightforward. Based on our experiments, we found some key insights about CNN training. For all the CNNs we tested, training always consisted of a small set of unique operations. Compute times of a given operation type, input size pair, can be estimated. GPUs typically execute one operation at a time. Therefore, a linear additive model using estimated compute times for different operations can result in accurate prediction of total training time. Ceer's linear model is shown in the slide, details of which can be found in the longer version of the slides and the paper as well. Ceer can predict the cost of training a given CNN on a GPU instance. Consider a scenario in which we want to minimize the cost of training Inception v3. Graph shows the performance across different GPU types. The hourly rate of one GPU of P2 instance is the cheapest, and the hourly rate of picking 4 GPU instances of P3 is the highest. We see that most cost effective from the graph is the one using one GPU for G4 instance. That's what Ceer predicts as well. In all our experiments, average prediction error for Ceer is about 5.6%, which is quite low. Thank you all for listening. I can take questions now. Here is my email address for any further detailed comments or discussions.